Good day, everyone, and to you, Miss Nestle Amaray, ma'am. Classmates, please bear with us today. By the way, we are the Group 5, and our lesson for today is about laminar and turbulence flow. We would like to introduce ourselves to you guys. By the way, I am Aliana Cherise Masani.
And this is Charlene H. Prieto.
I am Janelle J. Corbella.
I am Jessica Plaza.
I'm Alimar Eldonal.
I am Gisame J. Del Rio.
I am Mark Ariel D. Consina.
Again, I am Aliana Masanit, and as we start our lesson, let us have first our learning objectives. First is you have to describe the difference of laminar flow and turbulence flow. Have a deeper understanding of laminar and turbulent flow in pipes and the analysis of fully developed flow. Third, identify some example of laminar and turbulence flow. Fourth is understand the Reynolds number. Lastly, identify the characteristics of laminar flow. Here are the introduction. The distinction between laminar and turbulent regimes was first studied and theorized by Osborne-Reynolds in the second half of the 19th century. His first publication on this topic is considered a milestone in the study of fluid dynamics. This work was based on the experiment used by Reynolds to show the transition from the laminar to the turbulent regime. The experiment consisted of examining the behavior of water flow in a large glass pipe. In order to visualize the flow, Reynolds injected a small vein of tide water into the flow and observed its behavior at different flow rates. When the velocity was low, the dyed layer remained distinct through the entire length of the pipe. When the velocity was increased, the vein broke up and diffused throughout the tube's cross section. Let us first define what a fluid and what is flow. Fluid is a liquid, gas, and air. It is or other material that continuously deform flow under an applied shear stress or external force. Ang liquid and gases, gitawag siyang fluid kay they can be made to flow or move. Next is what is flow. Flow is the continuous movement of a fluid from one place to another. For further discussion, the movement of liquids and gases is generally referred to as a flow. It is a concept that describes how fluids behave and how they interact with their surroundings, environment. For example, water moving through a pipe or over a surface. Flow can be either steady or unsteady. So what are the two types of flow? We have here laminar flow and turbulence flow. And this will be discussed by Ms. Charlene Prieto.
And this is Charlene H. Prieto. So there are two types of flow in a pipe. First, we have here the laminar flow. So when we say laminar flow, it is a type of fluid. It's either gas or liquid. Laminar flow is characterized by fluid particles following smooth paths in layers, with each layer moving smoothly past the adjacent layers with little or no mixing. So when we say laminar flow, it is a type of flow which is ang flow sa fluid particles is ga-follow lang siya in a smooth fast layers. So kung unsay direction sa flow, mao'y direction sa tanan. Ga-flow siyang sabay but walay pagkahalo-halo. No mixing. Laminar flow has the same direction and the same speed. Or we can simply define the laminar flow as a simple flow. So we have here some examples of laminar flow, and that will be discussed by Janelle Corbella. So, Janelle?
I am Janelle J. Corbella, and for the continuation of Miss Preto, I will be going to discuss all about the example of laminar flows. First is the blood flow, second is the water balloon, third, aircrafts, fourth, viscous fluid, fifth, rivers or canal, sixth, fountains, and the last one is smoke. First is the blood flow. As Ms. Prieto said earlier, laminar means smooth, and so laminar blood flow is blood that's flowing smoothly or straight line through the vessels with no disruption happen. Second is the water balloon. Water balloon is an example of laminar flow. In real life or in a real situation, when we pierce the tip of the water balloon using sharp object such as knife, So the water flows through the resultant hole uniformly and appears to be not moving at all, or naka-static lang siya. The third one is the aircraft. The laminar flow of air means that there exists little or no mixing of the gaseous particles. So the laminar flow of air is an essential thing to ensure or in order to have a smooth flight because it allows uniform flow of particles of air over the surface of aircraft. Fourth is the viscous fluid. And to be specific, it is also called as a streamline flow. And this is belong in laminar flow because streamlines are straight paths and parallel. Hence, the particles move in viscous fluid is laminar layers, gliding smoothly over the adjacent layer. Fifth is the rivers or canals. These are prominent example of laminar flow. As we observe on certain rivers, the water flowing in smooth and the water body exists with no waves, which means that the different layers of water do not hamper each other and follow a straight pathway parallel to each other. Sixth is the fountains. In fountains, we can see that the flow of water is continuous with smooth flow of water. And the last one is the smoke. And to be specific, in a cigarette, as you have seen the smoke coming out of a burning stick of a cigarette, the stick on it is one of the main reason on why the smoke do not interfere with each other. It is because it allows the particles of the smoke flow in a smooth manner. However, when the smoke is scattered out, the turbulence flow will occur. In addition to examples of laminar flow is the taps or faucet. In real situation, when we're going to open a faucet, then obviously the water allowed to rush out. Then we can observe that the water appears to be parallel and static. As I have said earlier, when we say static, it is the amount of pressure exerted by a fluid that is not moving, or the water remain at rest. This is because the layers of a fluid flowing with low velocity do not mix with each other, thereby resulting in a laminar flow.
So laminar flow is subdivided into three types. We have here the unidirectional laminar flow, pulsatile laminar flow, and oscillatory laminar flow. So when we say unidirectional flow, a laminar air flows refers to air that flows in a straight unimpeded path. It is defined as the controlled airflow through the entire cross section of the clean zone with a steady velocity and approximately parallel streamline. So from the word airflow, air, so it's understandable that it's a type of flow in the air. Ga-refer siya sa hangin nga ga-flow in a straight or ga-flow in a one direction. So next we have here the pulsatile flow. It is an intermittent propagation of a fluid through a blood vessels or piping system in contrast to constant, smooth propagation which produces laminar flow. Next, we have here the oscillatory flow. Oscillatory laminar flow is accepted as means of simulating turbulences when using flow chambers. Although the flow is laminar, there is no main direction because the flow direction is changed at regular intervals. Although laminar flow siya, accepted gihapon siya nga turbulences because wala siya main direction. Dili pareha sa laminar flow jud nga same jud lang direction. Pero accepted gihapon siya nga laminar flow because wala sila main direction but ang ilang flow kung unsay direction is more gihapon direction sa tanan. Dili pareha sa turbulences nga ang iyang direction is ga-crisscross.
I have here another example for laminar flow. Go to your kitchen and open the sink. You can see that the flow of the water is smooth because all the water molecules move at more or less the same speed in the same direction. This is called laminar flow.
Before anything else, I am Jessica Plaza, and I am going to discuss turbulent flow. So what is turbulent flow? In contrast with laminar flow, turbulent flow is a complicated flow. It is a type of fluid flow in which the fluid undergoes irregular fluctuations or mixing. In a turbulent flow, however, the molecules in the fluid move in different directions and at different speeds. So when we say turbulent flow, it is characterized by the irregular movement of particles of the fluid. The fluid does not flow in parallel layers. The lateral mixing is very high, and there is a disruption between the layers. Additionally, in turbulent flow, the speed of the fluid at a point is continuously undergoing changes in both magnitude and direction. In other words, ang speed sa fluid in a turbulent flow kay dili constant in both magnitude and direction. So for further discussion about turbulent flow, Mr. Laminar will elaborate the topic.
Before anything else, I'm Laminar from Section BSA 1B. In behalf the discussion of Ms. Plaza for what is turbulence flow, and now I will continue to discuss about what is turbulence flow, o mas lalo natin palawakin kung ano talaga ang turbulence flow. The first sentence, the particles travel in irregular paths with no observable pattern and no definite layers. So the sentence are very understandable. It means there is no proper direction. Wala siya gibasihan nga pattern para dito nato ma-observe ang dagan sa flow, like for example sa tubig. Kung magbubuta sa yuta og tubig, kung makabantay mo scatter dayon na siya kay tungod wala may linya, shape or proper direction sa yuta para dito nato ma-observe ang pagdagan sa tubig. The second sentence, a turbulent flow can be either an advantage or disadvantage. A turbulent flow increases the amount of air resistance and noise. However, a turbulent flow also accelerates heat conduction and thermal mixing. It means the mixing of the turbulent flow enhances the temperature averaging effect in addition to the transfer energy from the hot water to the surrounding fluid. When a hot object is cold, the mixing action of turbulent flows in the fluid surrounding the object plays an important role in cooling it. And the last sentence, common examples of turbulent flow are blood flow in arteries, oil transport in pipelines, lava flow, atmosphere and ocean currents, the flow through pumps and turbines, and the flow in boats, wicks, and around aircraft wingtips. So, isa lang yan sa mga halimbawa na ma-observe natin ang turbulence flow, where how does the turbulence flow can observe in the based on the example. So, let's proceed to the given picture provided. So, in the first picture, it is very understandable. So, let's proceed to the second picture. So, guys, what is your observation based on the picture? So I explain it based on my understanding about in our topic. So the picture shows the turbulence flow. So asa na to makita ang turbulence flow based sa picture, based sa second picture. So ang turbulence flow nga gi-describe sa picture is mo nang nasa lower part nga area sa tubig nga nagikan sa gripo. Nganong sa lower part raman ngano sa taas wala. Means in the upper part, that is what we call the laminar flow, means only composed one direction, or it means the flow sa water is hanay siya, murag wala siya bubbles like ingana. So like for example, kung magpaagas tag tubig sa gripo, kung makabantay mo, labi na pag kusog ang awa sa gripo, ngano man ang dool sa gripo straight ra ang yang pag tagak sa tubig, nganong hamis man siya. So mo nang gitawag nga laminar flow. Tapos maobserbaran sab nato nga sa lower part na musayo-sayo na ang tubig, or murag nag-scattered ang tubig. Ug mana siya ang gitawag nga turbulence flow. So nganong turbulence flow man na siya? So kung ato mahinumduman sa second part o second sentence sa discussion about turbulence flow, which the turbulent flow increases the amount of air resistance and noise. So mo na siya ang dahilan nga no na turbulent flow. Then further discussion, because it caused by excessive kinetic energy in parts of a fluid flow, which overcomes the damping effect of the fluid's viscosity. For that reason, turbulence is commonly realized on low viscosity fluids. And for the next slides, we'll present by Miss Jason May Del Rio for the sample of turbulence flow.
Thank you, Mr. Donal. By the way, I am Gisame J. Del Rio, and for the continuation of Mr. Donal, I will be going to discuss and give some other examples all about turbulence flow for better understanding. As what we know about the definition of what is turbulent flow, it is a complicated flow. It is in contrast with a laminar flow because a laminar flow is considered when the fluid moves in a smooth regular path, but in a turbulent flow, it has an irregular motion with fluid layers mixing and disrupting each other's paths. Like for example, put a cup under the flowing pipe. The flow pattern of the water in the sink has become very complicated. This is due to the fact that now the water molecules tend to move in different directions at different speeds. Such a flow is called turbulent. If we put a cup under the flowing pipe or under the stream of water emerging in the faucet, like what we see in the picture, although the stream is still laminar, the flow pattern of the water in the sink has become very complicated. And this is due to the fact that now the water molecules tend to move in different directions at different speeds. Such a flow is called turbulent. Another examples of turbulent flows are smoke rising from a perfume stick. Similarly, the car exhaust fumes and the dispersion of pollutants in the atmosphere are governed by turbulent processes. The wake of a ship or submarine is turbulent. The rainwater on the road, the swirls and eddies in a fast-flowing river are also turbulent. Always remember that turbulence flow, it is in contrast with a laminar flow. If a flow has become very complicated or has an irregular motion with fluid layers mixing and disrupting each other's paths, that is called turbulence flow. That would be all about turbulence flow. And now, for the continuation of the topic all about Reynolds number, it will be discussed by Mr. Mark Consigna.
Good day, everyone. I am Mark Ariel D. Consigna. First, I want to say that the whole concept of Reynolds number is part of the Group 6. Amo siyang gi-include diri sa turbulence and laminar flow kay para mas masabtan ninyo ang amo ang topic. Amo lang gikuha is mga important details and information connected sa laminar and turbulence flow. Reynolds number is a dimensionless number that gives a measure of ratio of inertial forces to viscous forces and quantifies the relative importance of these two type of forces for given flow conditions. The Reynolds number help us to determine whether the flow is laminar or turbulence. If the Reynolds number is at low numbers, flows tend to be dominated by laminar flow. If the Reynolds number is at high number, the flow tends to be turbulent. Nganong gitawag og dimensionless number ang Reynolds number? Because ang Reynolds number is a ratio of two force, that is why it is dimensionless quantity. Also, dimensionless number siya because it gives the relative strength of the different phenomena, particularly ang duha ka forces which is ang inertia and viscous. Also, the dimensionless numbers are those which are useful nga para magdetermine sa flow characteristics of a fluid. Ang Reynolds number is nag-different siya between the turbulent and laminar flow ug mag-predict siya how it will flow in different fluid situations. One of the purpose of Reynolds number is to get ang sense sa duha ka relationship between sa duha ka forces, which is ang inertia and viscous force. The inertia forces is nag-define siya as density, velocity, ug length. It also connects to the Newton's first law, which is an object in motions remains in motion. While ang viscous force is mao na siyang dynamics sa viscosity of the substance. For example, if we multiply the three inertial forces together and we divided them by the viscous force, ang result ana is ang Reynolds number. If a substance at low Reynolds number, the viscous forces dominate and the flow pattern niya is laminar, which is ang laminar is a simple flow. For example, ganina, na go to your kitchen and open the sink, the flow of the water is smooth. Na it because ang water niya or ang water molecules is nag-move at more or less the same speed in the same direction. Mao na siyang gitawag og laminar flow. Mao pod na siya hinungdan nga ang iyahang Reynolds number is at low it because wala siya impact nga para magpataas sa Reynolds number. If a substance is at high Reynolds number, the inertial forces dominate, and the flow pattern will be turbulent because the turbulent flow is in irregular motion. It moves in different directions and at different speeds with no observable pattern and no definite layers. The reason also that the Reynolds number of the turbulent is high because the turbulent flow increases the amount of air resistance. Reynolds number formula. Reynolds number, average velocity, diameter pipe, absolute viscosity, fluid mass density, gravitational constant which is 32.2. Be prepared because the next will be the activity, assessment, and assignment. Thank you.
The activity, assessment, and the assignment. You have to answer it and send it to me for I have to record your scores and give it to Ma'am Amurai. Thank you and God bless.